Hey, I'm Brendan, and today we're going to be talking about converting programs in C to programs in ARM. So before we jump into an example, I think it would be helpful to go over some of the comparison and branching operations in ARM, because these can be pretty confusing at first and a little bit different from what we're used to in C. So to begin, let's first talk about what these first two operations are, CMP and CMPI. So the way we think about branching in C is generally within an if statement or within a while loop, for example. You might have some sort of comparison, and then that comparison has a direct effect on the program. So for example, in an if statement, if the comparison is true, then your code directly executes what is in the if statement, and if the code or if the comparison is false, and then the if statement is skipped. So ARM doesn't have that exact luxury, but we can recreate it using these commands. So first, what the CMP and CMPI commands do are they perform these comparisons on the registers or the register and immediate that you specify, but it doesn't directly cause this action. Instead, what it does is it sets these state registers that the program or the processor has, and then using those state registers, you can perform operations using these branch instructions. And so the way you might want to go about performing a check to see if x2 is greater than x1 is first you would call CMP x2 x1, and then if you had the operation b.gt, what you could do is specify a location that you would want to branch to after the b.gt, and what that would basically do is you could think of it as substituting a greater than sign there. And then if this condition is true, then it will branch to where you specify. Now the cool thing about the CMP and the branch instructions is that once you call CMP once, you can perform any of these operations on the same two numbers. So we could do a b.gt and then also a b.eq, and we would only have to call CMP once. Because remember, the way you might want to think about it is that the processor will have roughly 4 registers that it's going to be storing the results of the comparison into. And so we'll have these 4 values in the registers, and once we call CMP, those values are going to stay there until we call CMP a second time. And so if you want to do multiple comparisons on x2 and x1, you can do that as long as you don't call CMP with 2 different numbers afterwards. So that's just a high-level overview of what these instructions mean. Now we're going to walk through an example so we can really see this come to light. So now we're going to take a look at how we would go about converting this C program to ARM. So as you can see, this C program is just a very basic program, and what it does is it takes this global array called nums that stores 6 integers, so we defined array size equal to 6, and it just sums them up in this variable named sum. So just a simple for loop and array accessing that we're going to be implementing here in ARM. So I started with the first couple lines here in ARM. So we can see that the first 2 things that we're doing in the C code is storing the value 6 into array size and the value 0 into sum. So the way that we implement setting something equal to each other in ARM is using this operation called MOV, or move. And so the move is what it sounds like. It just moves a value into this register. So we defined before that array size is going to be stored in register x4, and sum is going to be stored in register x5. So that's why we used x4 and x5 here, and we stored 6 and 0. Now we want to go and implement the for loop. And so remember that a for loop really is doing 3 different things at once. So it's creating this variable I, setting it equal to 0. Then it's performing this comparison, I less than array size. And then at the very end of the for loop, it increments I. So the first thing that we needed to do was create this variable I and set it equal to 0. So again, previously we just defined that I would be stored in x6. And remember, these will usually be given to you at the beginning of the problem. And so since we're given that I is stored in x6, we move the value 0 into x6 to store 0 in I. And then we want to go on to perform our comparison. And so remember, like we were just talking about previously, the way we want to perform a comparison is by using the Cmp operation. And so this will set the state bits or our state registers that define whether I is less than array size, greater than array size, etc. And so we perform this comparison, and then you see we do a b.ge, which is greater than or equal to. And so at first, this is a little bit counterintuitive because our comparison here is less than array size, but this is actually a pretty common paradigm in assembly programming, specifically with ARM. And so what we're doing here is we're actually taking the inverse or the flip of this comparison and performing the behavior that would happen if this wasn't true. So remember that if I is less than array size, then we'll perform this for loop. But if I is greater than or equal to array size, then we'll just skip this for loop and start executing the code that's down here. So in this case, the code past the for loop is just nothing, but we can still say that we want to jump to that point. And so we define this label end, which will come after the for loop, and we jump to end if the x6 is greater than or equal to x4. So this will help us skip the for loop once we see that I is greater than or equal to array size. So that's how we would perform the actual check of the for loop. Now we'll go into how we want to implement performing the summation and accessing the array. So accessing arrays in ARM can also be a little bit counterintuitive at first, but it actually makes a lot of sense based on the fact that ARM is byte addressable. So first, think about how arrays are actually stored in memory. Remember that arrays have a very base address that the 0th element starts at. And so in this case, note that we just, again, by convention, said that the base address is stored in register x3. And then the following values after the 0th element in array come contiguously in memory. So in this case, we have a global array nums of type int. And let's just say, for example, that the base address is OX1000. So now, where would the element with index 1 be stored in memory? It's tempting to say OX1001, but remember, since an integer is 4 bytes, it's actually going to be OX1004. And then the second element is going to be 1008, and then third, 1012, et cetera, et cetera. So with this in mind, this is going to really help us figure out how we want to actually implement indexing this array. So first, let's try to figure out how we want to get this value, nums I, into a register. So first, it would be helpful for us to actually calculate this memory address that we want to access. So we know that the base address is stored in x3, so we're going to need that. And then we're also going to need to calculate the offset that we will add to x3 to figure out how far into the array we need to go. So first, let's calculate the offset. So we know that we're going to need to take the value I, and what we're going to want to do with I is multiply it by 4, because integer is of size 4. And so when I equals 0, we'll just access 1000, which is the base, and when I equals 1, it'll be 1004. And so to implement multiplication in ARM, what we'll use is the Lsl operation. So Lsl is, remember, that's equivalent to multiplying by 2 to the power of however many bits we want to shift by. And LSR would be like dividing by 2 to the power of however many bits we want to shift by. So in this case, since we're doing Lsl multiplication, we'll take I, which is in x6, and we'll shift it by 2. So this will be like multiplying by 4. And then we'll take this value and store it in a destination register. We'll use x7 since that's currently unused. So now that we have the offset, we can add it to our base. So now our temporary register x7 stores the memory address of the next element that we're trying to access. So now we can actually perform this load. And so to perform the load, we'll use LDUR, and then we'll use the SW variation. So the reason we'll do this is, first, the W means word, and so we'll load a word because nums is of type int, and an int is of size word. And then we'll do the sign variation because if there are negative integers in this array, then we'll need to make sure that we're grabbing those sign bits as well. So we'll load this word into, again, just our temporary register. And this is at address that's stored in x7. And now, remember that we also need this displacement immediate. We're actually just going to use 0. And so this can be a little bit confusing at first, why we're not just putting in the register value, for example, maybe like x6 times 4 in here or something like that. But in the legv8 version of ARM, we don't have the capability to put a register in this place right here. And so that's why we need to perform these operations before we actually do the load. And then since we don't need the displacement field anymore, we just put in the value 0 instead. So now we have nums I stored in x7. So now we can actually go ahead and just add that number to sum. So this line here, add x5, x5, x7, we'll take x5, which is sum, plus nums I, and then store it back in sum. Now that we've done our summation, the last thing we need to do is the third part of our for loop here, which is incrementing I. So we will use add immediate, which is the same as add, but just adding a constant value instead. And remember, I is in x6. So we add 1, and then we want to jump back to the top of our loop to recheck our condition. And so unconditional branching in ARM is just simply the operation B. And then we'll branch to the top of our loop. And that is how we would go about converting this C program into an ARM program.